Hello everyone, this is Kalpana. I am working as an assistant professor in SNS College of Engineering in AI&DS department. This lecture series is on data structures and algorithm. It belongs to second year AI&DS students. Next we will see what is data structure. That is the definition of data structures. So here a data structure is a way to store and organize manipulating data in your computer memory. Okay, we are going to store and organize, that is we are going to arrange our data in our computer memory for doing any further manipulation kind of thing. And the next thing is related data, that is your data plus your permissible operations on that data. Operations like we are going to insert any data, we delete any data, we modify, we update, we remove, we do all kinds of operations. So data plus their operation together we call it as data structure. I'm having a data. With the data I'm going to perform some kind of operations. So that I'm going to call it as data structures. And we say examples of data structures are list, array, etc. So list, we all know mark list. We save mark list, right? Student name will be there. Against that student name, marks, we can store marks here. So here the marks are in an arranged manner. It is in a linear fashion and it is in an arranged manner. So we call this as a data structure. So list is also a data structure. Arrays you may have studied in your previous classes. So it comes under data structure. So likewise we have so much of data structures. We will see one after another. And our next topic is importance of data structures. Why data structure is very much important. So the algorithms can become considerably simpler, easier to handle and faster by adding structure to data. If as I told you, we do not follow any kind of format or any arrangement, then it is a tedious process to fetch any data or to feed any data into the system. So we must follow some kind of organization technique in order to handle the data. So the process becomes very much simpler. Okay. And the next thing is to manage enormous quantities of data. So we we are handling huge amount of data every day. So to handling those amount of data, obviously we require a data structure to handle it. And next is to efficiently retrieve and manipulate the data, like fetching and manipulating, doing some insertion, deletion, updation, modification operations. Obviously we require a data structure. If the data structure is there, we are following an organized manner of storage, then it is very much efficient for us to manipulate. That means performing any operations on the data. And next is characteristics of data structures. It's like we can say attributes or properties of data structures. And the first one is static and dynamic, correctness, time complexity, and space complexity. So static and dynamic, it deals with the static in the sense fixed memory. So during the compile time itself, we fix the memory. Like say for example arrays, it comes under static data structure. And dynamic in the sense during runtime the memory will be fixed. During runtime the memory will be allocated. And the next is correctness. It ensures the correctness of the data because everything is an ordered way. So it ensures the correctness of the data. And the third one is time complexity. It is a time consuming one when we go for data structures. And also space complexity. Like it takes less space when compared to unorganized one. Next is operations on data structures. So these are some of the operations we can perform on data structures. So like insertion operation, deletion operation, sorting, searching and update. So we know insertion means inserting elements or inserting any data. Deletion is removal of data. Sorting, that is arranging data A to Z, 1, 2, 3, something like that, ascending or descending order. We can perform searching for a particular, finding a particular value in the list. Like updating, which means modifying the current value, something like that, it comes under update. So these are all some of the operations we can perform on any data structures.